Hello students, I hope you are doing beautiful mathematics. In this video, we will learn about an important concept related to mathematical Olympiads such as IOQM, American Math Competition, UKMT and so on. This concept is also useful for ISI and CMI entries. First, I will explain the concept with some problems and then I'll also give you a challenge problem. If you can solve it, please put it in the comment section. This concept is about the concept of locus. So I'll explain it with an example first. Suppose you have a point O which is fixed and there is another point P which is moving. But this point P is not moving randomly. It is not moving randomly, but it obeys some rule. The question is, if the point P moves, obeying that rule, what is the path traced out by the point P? What will it look like? What will the path traced out by the point P look like? So in your mind, you have to actually train your mind to imagine that the point P is moving, and while it is moving, it's tracing out a path. That path that the point P actually traces out while it's moving, obeying some rule, is called the locus of the point P. So locus is simply path traced out by point P. So what can be the rule? Well, the rule can be something else. From problem to problem it can vary, but every time you will get a different shape. For example, let's say the rule is this, that the point P is always 3 units away from the point O. That is, the moving point is always 3 units away from the fixed point. It's very easy to imagine what will happen at that point. Well, it will create a circle. This is a very common way of defining a circle, but I will point out two sort of different viewpoints at looking at the circle. The first viewpoint is the one that I just explained. It's a dynamic viewpoint. You actually imagine in your mind, you imagine this circle being produced as the point P is moving. You can train your mind to think like that. The point P is moving and the path is slowly getting traced out and now it's creating a circle. It's a dynamic thing that's happening in your mind. So this is a dynamic picture. The circle is sort of appearing in front of your eyes. The second idea is actually a static picture. The static definition of a circle is this. It's a collection of all equidistant points from O, the fixed point. So you are now thinking about this entire circle together. You are thinking about it as a set of points on the plane which are equidistant from a given point. You get the same thing, but there are, if you see what I'm saying, there are two complete viewpoints. There are two completely different viewpoints. So both of them are important. One of them is important in some concept, the other one is important in some other context. Now let's work on another problem, another example, okay? Another example. This time, let's pick 2 points, let's say O1 and O2, and suppose both of them are fixed. So this is fixed, and another point P is moving. The point P is moving, but it's not moving randomly. It moves following some rule. What is the rule in this case? Well, The rule is this, that PO1 plus PO2, PO1 plus PO2 is 5. So instead of having P to some point as a fixed number, P to the first point plus the P to the second fixed point, that is fixed in this particular case. Here is a challenge question. Can you tell me what will the path traced out by P look like? What will it look like? And it's also given that O1, O2 is 3. O1, O2 is 3. The distance between O1 and O2 is 3. What will be the path traced out by P look like? This is a very important figure. Mostly all of you know about it, either from mathematics or from geography. But I think you will have a lot of fun thinking about it. Again, you have to train your mind to imagine that the point P is moving, keeping P1 plus P2 constant. Just knowing the answer is not important. It's also a training of your brain muscles. Can you imagine the point P moving and PO1 and PO2 sort of adjusting with each other so that their sum remains always equal? That imagination is the key learning of this particular graph. Okay, so that's the second example. If you know the answer, put it in the comment section. This is the third example. Let's take a third example. Suppose we have a circle which is of diameter 4. So this is center O. It's a 4 centimeter long circle. The diameter is 4 centimeter long. And there is another circle. So this is a fixed circle. Now the circle is fixed. Okay. Earlier we had points fixed. Now we have circle fixed. And now we have a moving circle with diameter 1. This is a moving circle. Okay. And we have a point P on the end of the moving circle. P is on the moving circle. Okay. Now imagine that this small green circle is rolling on the circumference of the fixed big circle. The big circle is fixed. The small circle is rolling like this. And as the small circle rolls, the point P, which is on the small circle, that also starts moving. Think about it. The small circle is rolling. The point P on the small circle, that is also moving. Can you tell me what is the path traced out by the point P? How will the path traced out by P look like? Thank you for watching this video. I hope you learned something. If you are an internal student of Cheenta in mathematics programs of level 4 and above, make sure you are attending for 4 to 5 days of problem solving every week. Make sure also using the software. If you are new to Cheenta, this admins will give you access to all of these things pretty soon. If you are an older student, then keep on working really hard. Also, many of you are participants of the research projects at Cheenta or entrepreneurial projects which are part of the Path to Ivy League program. Make sure that you are in close connection with your mentor, because this is a long journey. We want to slowly build it. And as you already know, some of the Cheenta students have been to the greatest universities in the world, Harvard, MIT, Stanford, to name a few. So make sure to stay connected with the entire process of Olympiad research and leadership. These 3 things will shape your journey toward this wonderful academic career. Okay. Thank you for watching. Take care. I'll see you in the next one.